All right, so hello everyone, and welcome back to the channel. I know it's been a while since my last upload, but I've got a really fun video for today, and it's how to make game-style physics using Matter.js and React Native Skia. So guys, as always, the repo is in the description that we're using today. The main branch has all the solutions, but the starter branch is the branch that you want to use if you want to follow along today. Today, we're going to go over three topics in this project. The first is going to be how we sync up Skia and Matter.js. The next one is going to be creating walls. And the final one is going to be how we can create a nice little projectile that makes all of our boxes and things in our world explode that I think is really fun. All right, guys, I'm excited. Let's get into the coding. All right, guys, so before we get into doing any type of coding, let's first talk about, on a high level, how everything sort of works together. And there's kind of two parts to this. There is the matter part, which is our physics, and then there's the Skia part, which is the sort of UI part. So let's talk about matter first, because this whole thing is sort of a game of kind of getting matter and Skia to talk to each other. And we kind of probably already know what Skia does, especially if you watch this channel a lot. So I wanted to start with matter because it's new, and then we'll move on to the Skia part. The way that matter works is it has a number of different objects, and all of those objects have to be put in the matter world. The world is basically an array, and on every frame, it loops through the entire array of things that you have in order to figure out whether they've collided, and if they've collided, whether or not they should bounce off of each other. So within the world, you can have things like a rectangle, you might have like a circle, and so on and so forth. And so for each of these properties, you can set a number of different physics values. You can set like the velocity, for example. You can set the mass. You can set like height and width, obviously. The sky is really the limit in terms of what you can do in terms of the Matter.js and the physics. So with respect to Skia, what we have to do is we have to maintain basically a mapping between matter and Skia, because matter is going to be our physics, and the matter world is going to run on every single frame and figure out what's collided with what and where things should go. So with Skia, let's draw our screen out, something like this. And what we have to do is, in matter, matter will give us the x and y coordinates, the width, the height, and the angle of rotation for every single object in our world. So if we have a square here maybe, and there's a square here, maybe it's angled a bit, and something down here, and something down here. Basically what we have to do is, none of this is visible, because all of the stuff that's in black here is the matter stuff. In order to make it visible, we have to overlay every single matter coordinate with a Skia object, whether it be a rectangle, whether it be a circle, whatever. Matter gives you the coordinates and the width and height, as well as the angle of the rotation. Whereas with Skia, we use those values in order to actually place them wherever they need to be on the screen. I'm going to come back to this, I think, a couple times and maybe go into a little more depth here and there. But basically, this here is sort of the gist of how Skia and Matter work together. And so the first thing I want to do is just get some rectangles on the screen. So let's go and do that now. So guys, like I said, let's get some rectangles on the screen. As always, the repo is linked in the description. If you go to the starter branch, that's the branch with this bit of boilerplate, and you can use that to follow along. Or you can just use the main branch, and in the main branch, the whole solution's there for you. Up to you what you want to do. But right now, what we're going to do is start by creating an interface for our box coordinates. And inside here, we're going to put everything we need from matter that needs to go into Skia in order to get things moving. So x is going to be a shared value, and it's going to take in a number. Y is going to be the exact same thing. We're then going to have an angle because our squares are going to need to rotate later on. And this is going to be a bit of a weird type, but it's kind of necessary because this is just how rotations work in Skia and in React Native in general. We're also going to need an origin, so a place for the rectangle to rotate around, and that's going to be an SK point. So just like an XY point on the Skia canvas. The width and the height are just going to be normal numbers because those don't animate. The square is always going to stay the same shape. And then the type is going to be box. And we need a type because we're going to have a circle as well that we're going to make in just a minute. So quickly, guys, let's create a type and call it game objects. And as we go, we are going to add the various objects of our game here into this type because we're going to need to use like some type checking inside the loop later that goes through all the objects and do certain things to different objects. You'll figure it out in a minute. It'll be easy to kind of see what we're doing. At this point, though, what we're going to do is create the world. So we're going to say matter.world.add. And of course, to add a world, we need a world. So let me quickly make that for us. So we have our physics engine. And in the physics engine, we have matter.engine.create in order to create it. After that, to create the world, so the place that contains all of our different matter physics objects, we're going to do engine.world. So back down here, we have our world, but for now, we're also going to add an empty array. This array is going to get populated with different objects later on, but for the sake of initializing things, that's kind of all we need in order to get started. All right, guys, so now that we have our world initialized, the next thing that we need to do is to be able to add objects to our world. And like I showed in that diagram earlier, what we're going to need to be able to do is keep Skia and the Matter world in sync. On the Skia side of things, or the React side of things, we're going to create an array called elements, a state called elements that's going to be an array. And this is going to contain the game objects. And I'm going to initialize this to an empty array. There's not going to be anything in it in the beginning. I'm also going to have the boxes world. This is going to be our matter objects. And so we're going to have to keep these two in sync as we go. So guys, let's actually create some box coordinates and use that to populate some things on the screen. Inside of your add box prop, let's create some coordinates and call it new box coordinates. I'm going to make that the box coordinates type so that I don't forget anything. For the initial X position, I'm going to use make mutable, and I want it to be just slightly off from the center of the screen, so I'm going to add 40 here. By the way, guys, what is make mutable, right? Make mutable is basically similar to the hook use shared value, but the difference is you can call it imperatively. So guys, use this with caution. Software Mansion does not recommend you use it very often, but in these cases where the number of items is perfectly dynamic, you have no other choice, and so that's why we use it here. So let me make another shared value, and the Y position is going to be 200. So this is just the starting position. These could have been any numbers. These are just numbers that I happen to like. So the angle of the box, when it starts off, is always going to be 0. Because obviously you haven't made any changes to that yet. And it's got to actually be an object. And then finally, the width is going to be the box size. The height is going to be the box size. The type is going to be box. Oh, and finally, the origin is going to be equal to make mutable. And of course, we need to set the origin point for the actual square itself. We need to basically find the middle point of the box as the box moves around the screen. So for now, the center point of the box, like the X and Y coordinate, is going to start at the exact same point as the width, but actually it's going to be the box size divided by 2. Then for the y position, we're going to take 200, which is y, divided by 2 to get like the middle of the square vertically. We're then going to add the box size divided by 2 to then control the offset for that. And I need a thing here. So guys, I realized my explanation of the vec as the center point in the last section might not have been super clear. So I wanted to whiteboard this really quick to make things maybe a little more clear. So let's keep this thing in mind with Skia and how we need to wrap these different boxes in the Skia object. Sorry, the Skia component. Basically what happens if you have a screen, something like this, and you have a square, on every frame, that square is going to move somewhere. But when you rotate in Skia, so let's just take the screen out of it. Let's use a square like this. If you just rotate without setting the origin, it's not going to rotate based on the middle. Like the rotation's going to go like over and around here, and it's going to be kind of strange. To rotate properly in Skia, you have to tell Skia that the middle point is here, and then only then will Skia know how to actually rotate this. So like rotate it like 45 degrees that way or something, right? So as we go along with the movement of any individual square, we have to keep track of the midpoint as it moves around the screen. And that's what that vec thing is. I hope that made things a little more clear. So guys, now that we have those values in place, I'm going to also keep track of an offset value because I want a little bit of variety in where my boxes land. And I'm going to create this as a ref, and it'll just default to 0. So what we're going to do is we're going to say offset.value, .current is going to be equal to the offset.current plus 1 every single time modulo 2. And that will allow me to kind of have some variety in where the boxes end up. Finally, I have to create a box that Matter can use, but I can use my Skia values in order to keep these in sync. So I can say matter.bodies.rectangle, and inside here, I put my new box coordinates.x.value. And then to that, I'm going to add my little offset I created above. So offset value, offset.current. I keep getting confused with reanimated, I'm sorry. And the box size. I don't have to do anything for y. So for y, I'm just going to use the exact same value because I'm not going to offset y at all. The height and width of this is just going to be the box size. And then I'm going to use this value called restitution. All this does is make it kind of bouncy. It's not super interesting beyond that. Now inside here, we're going to say matter.world.add, and we're going to add to the world that we pass in the new box we just created. Along with that, I'm going to call set elements, and here I'm going to add my new box. And then in my boxes world, I'm going to push the new box. And of course, that's a little bit weird because I did not type it. And because we forgot to type it, let's make this a matter.body array. And cool, our array's happy now. So now that we have all those coordinates, we're not going to be able to move anything yet, but let's actually render these things to the screen. It's going to look weird because they're not going to move and they're not going to do anything, but at least we can get them showing, right? So we're going to get our box and the index from the elements, and then we are going to return a Skia rectangle, And the rectangle is going to have a lot of stuff in it, so I'm going to put one of these around it. Its x position is going to be the box.x, box.x. Y is the same. The height is going to be the box height. By the way, this is how we kind of map the world to the different Skia components. That's what we're doing now. Box.width. After that, the color is going to be lime green. You know we love lime green on this channel. I always use it. My key is going to be equal to the index above. The style is going to be stroke just because I like it. The stroke width will be 3. The transform is going to be equal to that rotation that we have with the angle. And finally, the origin, which as we know is the center point, is going to be the box.origin. Okay, so if I click add box now, we can see a box rendering to the screen. And actually there's many rendering to the screen, but because they're all in the same spot, you can't see anything. Okay, let's go through and let's allow these things to move. And the way we do that is by creating a bit of an infinite loop. Because remember, on every frame, we have to check this. However, the infinite loop is not the use effect. So what we do want to say is every time there's new elements, we want to update our loop. And then in the Matter engine, we are going to update it by first passing the engine in and then doing 1000 divided by 60 so that we can get 60 frames per second. After this, I'm going to have an animation frame object. And I'm just going to make that an any type. And this is going to update every single time that we go through our loop. So I'm going to create a function for updating. I'm going to put our engine in there. I'm going to say that the animation frame is equal to the animation frame that we're going to request. And pass update as our callback to that. And we're going to loop through all of our elements. Then for each element we go through, we're going to say that the element dot x dot value is going to be equal to the box's world dot current at the index dot position dot x. And of course we can do the same thing for y because they're both just numbers. Now things get more complicated a little bit. So for the element angle, what we need to do is we need to say that the angle gets put inside of this rotate structure. Just like that. And if you remember from earlier, we always have to keep track of the center point of the box. And the way that we do that is through the origin here, like we said. And so to get the middle of the object, we say the element dot x dot value. And we know this is correct because this value is always moving along with the square itself. So this value plus the box size divided by 2 is going to be the middle. And we can make the same exact assumption for y. So now we call update at the bottom of this. So that update gets called every animation frame. And in order to clean this up, we will cancel animation frame when we're done and pass our animation frame into there. So let's see if that worked. And as you can see, we're getting boxes dropping. They're colliding with each other a little bit, which is really cool. But they're, of course, falling through the floor, which is not what we want. So let's go back and fix that. Actually, guys, a quick correction here. This shouldn't be ball size. This should be box size. I think the autocomplete kind of burned me there. For now, it looks the exact same, but I promise you, once we have walls going, it'll make a pretty big difference. Okay, guys, so let's quickly go in and talk about walls. And walls are kind of strange. So as always, we have our phone screen kind of like this, and we want the walls to be the top, bottom, left, right, and so on. Weird thing about walls is that you kind of have to start them from the middle and then sort of expand them out from there to the left and the right hand side. I don't know why our normal coordinate system doesn't work, but this is something you kind of have to keep in mind as we work with creating the walls and stuff like that. Something important to keep in mind about the walls is the thickness as well. For today, on the left and the right hand side, I'm going to keep today's walls pretty thin in order to keep the tutorial simple. What this means though is that if an object is sufficiently fast, it'll actually just kind of pass through the wall. In order to keep things simple today, I was able to do that just because I didn't want the video to go on too long. But if you are working on something yourself, you can pretty much just copy exactly what I did for the walls in terms of setting them like the right width and height and the right position. But all you'll need to do is you'll need to create a little bit of an offset, and you'll need to make your wall thicker, because the thicker the wall, the more able it is to tolerate speed from, say, the ball going this way or this way really, really quickly. For this section, though, I'm mostly going to focus on just positioning the walls. Like I said, it always starts in the middle point and expands out from there, which is kind of awkward. And we're going to repeat that pattern for the walls on the top, bottom, left, and right. And hopefully by the end of this, we should be able to keep our squares nicely inside of our box and not have them flow outside the screen. Okay, let's give this a shot. Okay, guys, so in order to make the walls, we're going to go back up to where our world is originally created. Because we only need to add these in one time, I'm just going to basically start them in the world because there's no reason not to do that. Also, our walls are going to be invisible because they're literally just going to be the edges of the screen. I thought that looked cool, so we're going to stick with that. Our top wall is going to be equal to a rectangle, which we're already kind of familiar with. The starting x position is going to be width divided by 2. The starting y position is going to be 0, so the top left. The width of it is going to be the width of, the width of the screen. And then the height of it is going to be 1. Finally, we're going to say that it is in fact static, because it never moves, of course. Okay, so for the bottom wall, we do something pretty similar. And we'll name this wall. Oh, bottom. Same thing, starts at width divided by 2. But then, for the bottom part, we're going to do the height of the screen minus the bottom height. So that's all the way at the bottom of the screen, but with a little bit of an offset, just to keep it away from the iPhone's safe area. And then we're going to use the width as the width, of course. And then for the height, I'm going to give it the bottom height. And again, is static is equal to true. So at this point, let's test it out. And let's see if we can hold things to the bottom wall. And things are leaking out the left and right, but of course the bottom wall is working, which is great. So let's do the left and the right. So for the left wall, we are going to say that we want to make another rectangle. But for this rectangle, it's going to be offset to the left by the size of the ball. That'll become relevant a little later when we actually have a ball. The y position is going to be height divided by 2, so the middle and the height. The width is going to be 1. and the height is going to be the height. And again, is static is true. Then for the right wall, it's pretty similar. The difference is, of course, that this time we're going to do the width minus the ball size in order to position it on the x-axis. Height still height divided by 2. 1 is our width. And then for height, I can keep that the same. And is static is, of course, true. So, all right, let's add in the left wall and the right wall. And let's see if we can stop the leaking. And of course, the leaking is stopped and all of the boxes fit in really nicely. All right, guys, let's finish off with the ball and getting the ball to explode all of the rectangles. Okay, guys, so let's now make the ball and fire it as a little projectile. For the ball coordinates, we're going to need a type for this as well. It's also going to have an x and y that are shared values. But this time, for its size, it's only going to have a radius, and that radius is a number. But we don't need rotation or anything like that, because of course this is a circle, and you can't really, well, you could rotate a circle, but it's always going to look the same. That's not going to really make much difference. In terms of the game objects, I'm going to then add that to my game objects array. Now what we need to do is, outside of the component, I'm going to create the ball, just because we're only going to have one ball. We don't have to dynamically render it. Similar to the recipe for the box coordinates, I'm going to first create the reanimated coordinates. And I'm again going to use make mutable. And what I'm going to do is make this a little dynamic. So I'm going to say the width multiplied by 0.15 is going to be the place where I'm going to put it on the x-axis. And then for the y-axis, I'm going to do the same with height. But I'm going to place this at 0.85. The radius is going to be the ball size that we mistakenly typed earlier, and the type is going to be equal to ball. So now I need a ball as well. And we do this using Matter's bodies and creating a circle. So its x-coordinate is going to be the ball x-coordinate value. The y-coordinate is going to be the y value. And then the ball radius is going to be, of course, the radius. And it's going to start by sleeping. And I'm going to give it a restitution of 0.9, just like we had for the rectangle. And then add that to the world array, just like this. And I'm also going to add it to our little boxes world here and add the ball coordinates there as well. And I see we're getting an error. Gotta figure out what that is. Okay, guys, so I figured out why it was crashing, and it's because basically Skia does not know what to do with it yet, and Skia will just kind of hard crash when it doesn't know what's going on. So let's fix things up so that the right thing will get rendered with the right coordinates. As you can see here, we have some type errors because we don't know if it's a rectangle or a circle. So let's fix that. We're going to say if the box type is equal to the box, and I could probably use a better name than box type. It could be just any object, but that's what we have for now. Otherwise, we're going to render a circle, and that circle is going to have an x and y that matches that, and the radius, oh, I should do an else if, just so that the type is very explicit. If it's a circle, or ball, I guess, and then the radius is going to equal to the object's radius. So it's actually Cx and Cy. I always forget. Okay, so if I reload, I still don't have anything yet because we have not updated the update function. So let me fix that as well. So same type of thing. If the element is a box, or element.type, I guess. This is what we do. Else if the element type is ball, what we do is we adjust these two values and nothing else. And actually I got to return the circle as well. Whoops. All right, so to get the circle to show up, what we need to do is make its key equal to I. We need to make its color equal to lime green, just like the boxes. And then back up here, I just remembered I need to add the ball size to the position. Okay, so if I reload, we can see that the ball is now here, and things should just bounce off it. And as you can see, they do. So everything will wrap around the box nicely. The box exists. All right, guys, so let's get the box flying around as a projectile. To do this, we'll first need to fix our offset here and change it to the box size instead of the ball size. Doing this will allow our boxes to stack just like this. And then the next thing we'll have to do is create a little function for the ball to allow the ball to move around. So we're going to call this one launch ball. And when the ball is launched, we're going to set its sleeping status to false. So it's no longer going to be asleep. After that, we're going to set its angular velocity to 5. And then we're going to set its velocity, so the velocity of the ball, to be x, where x is 60, and y, where y is equal to 0. Finally, in the onLaunch ball function, I'm just going to plug this one in here. And let's see if it works. So I'll add a few boxes here just so we have something to crash into. And if I launch, as you can see, we can smash all the boxes, which is really awesome. And if I reload, and I can do it a couple times just for fun. But there we go. All right, guys, so we learned all about Matter.js today and using Matter.js physics in a React Native Skia app. I hope you guys enjoyed this and had a lot of fun. As always, happy hacking.